Now, looking at question 2, I think it must have been exciting to come across this type of a question because it's straightforward, really. They didn't do a lot of tricky things this time around. Now, when we look at 2.1, we are told here that we are given an infinite geometric series. Now, when they say an infinite geometric series, it means it goes on until infinity, it doesn't stop. That's why here at the end, you see that after the plus there, we have 3 dots to say the terms continue until infinity. And of course, when you look at this, it's a series because it has the addition that we are adding terms in this series and they're given in terms of a variable t. So each term there is given by the variable t. Under question 2.1.1, we are then requested to show that the value of t is really equals to -2. Now, to then answer that question, we have to take advantage of the properties of a geometric series or even a geometric sequence. In a geometric series or even a sequence, we know that we have the common ratio, meaning if you divide the successive terms, you should be able to get the same number. So that means that I'm going to say R is equals to, if I say term 2 divided by term 1, I should get the same value when I say term 3 divided by term 2. So what am I saying here? I'm saying if I take this term here, I divide by that term, I'll get a number. That number should be the same as when I divide this by that. And that's what I'm going to do really in this question. I'm then going to substitute the terms that we have there. This would imply that the term 2, which is given by t minus 2, and we're going to divide that by the term 1, which is given by t plus 10. This should be the same as taking term 3, which is given by t plus 4 divided by term 2, which is t minus 2. Then from here, we simply have an algebraic fraction. We know this from grade 10. We've been doing simplifying or solving algebraic fractions. Now, to solve this, what we're going to do really is that we're going to use a method of cross multiplying. I'm going to cross multiply these 2 here so that I'm going to have t minus 2 whole squared. Remember, these are 2 terms that are exactly the same. So this will give me a perfect square. It's like it's a binomial that's a perfect square. Then I'm also going to cross multiply these 2. And for cross multiplying these 2, I'm going to have a t plus a 4 times a t plus a 10. And from here, really what we do is that we expand our binomials. Again, I always even give an advice when we're doing our prediction to say, if you master question 1 of mathematics, you will be able to master the whole of the question paper 1, and even paper 2. Why? Because it's a repetition. What we're doing here is exactly what we did when we solved for x. And to expand this, we all know that there's going to be a t squared minus 4t plus a 4. For this one to be expanded, I'm going to say t times t is going to give me a t squared. Then I'm going to say t times a 10. What I have here is really going to be a 10t. Then I'm going to say 4 times the t. This is going to give me a plus 4t. And it means when I combine these 2 here, I should get a 14t. And this is why here in the middle part, I'm really going to have a plus 14t. The last term that we're going to multiply is going to be a 4 times a 10, which really gives me a 40 there. Now, from here, we are going to group our terms and put them on one side. I can see that the t and the t cancels each other out. Then the other thing that I'm going to do is that I'm going to group the numbers that have a variable of t. So I'm going to take the 4 to this side so that I have a plus 4 here. So 14t plus a 4, that should give me an 18t. So I'm going to have an 18t, and then I'm going to say is equal to, I'm grouping here the numbers now, the 40 and the 4. Because I took this to this side, I'm going to then take the 40 to this side. So that means I'm going to then have here a 4 minus 40, and that should give me a negative 36. 18 really goes 2 times into 36, and this side it cancels. I'm only left with a t. So our t is equals to a negative 2. And really, this is what the question was asking us to do, to show. Therefore, we can say, hence shown. We were able to prove that. And you should be smiling if you get a number like this, because it shows that you got the answer correct. The 3 marks here will come from the fact of equating the two, saying that you have a common ratio, simplification, and your final answer as well. Now, moving along to the next question, we are looking at question 2.1.2, which says calculate the value of the 25th term. We're looking at T25. And we are requested here to write our answer. Write your answer in a form of Tn is equals to b to the power x. What they're saying here is that we should write our answer in exponential form. It should be in exponential form. So we should not give the exact value. We should simplify it such that it's in exponential form. Now, to answer this question, we need to construct our series. What I mean by that is that we already know that the value of t here is a 2. So we need to put this in numbers so that we can be able to simplify this. So here I'm going to say I'm having negative 2 plus a 10. This is the first part here. And negative 2 plus a 10, that should give me an 8. So I'm going to have 8 here as my first term. And the second term here, I'm going to have a negative 2, and that gives me negative 4. So that means here I'm going to have a plus negative 4, and this would give me negative. So it means I'm going to have a negative 4. And the last one, we're going to have a negative 2 plus a 4, this one here. And of course, we can see that that is going to be a plus 2. But because this is an infinite series, it will continue going on until infinity. You can add the terms just like that. Now, from this stage, we can then see that our common ratio is going to be negative 1 over 2. Because, if you say here negative 4 divided by 8, it should give you negative 1 over 2. Even if you say a 2 divided by negative 4, here you should get a negative 1 over 2. That is our R there. And the first term is given by T1 is equals to A is equals to an 8. Now from here, we can then go to the equation that says if you want any term in the sequence, let's say we're looking for 25 in this case, is going to be given by A R to the power 24. So this equation says that we're having a term number here 25, and the R here should be 1 less. It's a shortcut equation that you can use. Or if you like, you can use the original equation where you say A R to the power n minus 1, and you can substitute and build on that. Try that and let me know how it works out for you. But I'm going to stick with this one, where now I'm going to say that our first term is an 8, the R is negative 1 over 2, and here we're having a 24. But remember, they said we should put our answer in exponential form. It should be in a form such that we have b to the power x. That means I'm not going to use a calculator here, because if you punch a calculator, you'll just get a big number here. And that might make you to lose marks. You don't want to lose marks. What I'm going to do here is that it means I'm going to play around with exponents. I'm going to change the 8 to a power so that it becomes now 2 to the power 3, because we know that 2 to the power 3 gives us 8. So now in the brackets here, I'm going to have a 2 to the power -1, and I'm having 24. Now here I'm using the laws of exponents that says if you have a to the power -n is the same as 1 over a to the power n. So I'm moving from this side and going backwards because I'm having here this, and I'm taking this back to the exponent form. So we should have a -1 there, because remember the 1 here is raised, the 2 is raised to the invisible 1. And from here, we are going to have our 2 to the power 3. Remember now here we still have a negative. We still have a negative there, very important. Now we're going to have a 2 to the power 3, and inside the brackets I'm going to have a -1 times 2 to the power -1 to the power 24. All I did is that I separated these two and multiplying it by 1. Now from here, I'm going to have a 2 to the power 3, and I'm going to use a rule that says if you have a to the power n multiplied by a to the power m, and we have an r here, this is the same as a to the power rn times a to the power mr. So the r multiplies each exponent there. So the same thing here, the 24 would multiply the exponent here, 1 to the power 1, and it will also multiply this one here. So that I have now here -1 to the power 24. So here we're having -1 to the power 24, and here we're having 2 to the power 24 here, because the 1 and the 24 will give me that. And we are going to have 2 to the power 3. Notice that if you take this power here, you're going to get a positive number. You're really going to get a 1 there. And this would be 2 to the power 24. Now, at this stage, we are then now going to, if you multiply any number by 1, it's just going to be that number. So technically here, I have this 2. So it means I'm going to apply the laws of exponents where I keep the base and add the exponents. So I'm going to keep the 2 and add these 2. Going to add a 3 minus 24. 3 plus minus 24 is a 3 minus 24. And if you multiply, if you combine those two, you should get a -21. So here we'll have a -21. And therefore, that is our term 25. Do you see that this is in a form of b to the power x? Because our 2 here is a b here, but our x is a -21 there. So that's the form that they wanted us to put in. And this is a very interesting way of asking questions, because they're literally forcing you not to use a calculator. And this is for 3 marks, and I know I took a lot of steps because I just wanted to justify my answer, how you get to the final answer. So for 3 marks, it means they're going to give you a mark for substituting here, simplification, and really getting to the final answer. That's how you get the whole 3 marks. Moving along to the next question. Question 2.1.3, they say calculate the sum of the infinite series. Now remember, to get the sum to infinity or of an infinite series, you really have to know that your r should be between -1 and 1. And if you check, our r is -12. So it is in between that range. It means we can actually calculate the sum. It exists. It means the sum to infinity exists. So this is to say that if you add the terms, they converge. They go to a certain number as you add the terms in this series. So as you add as many terms as possible in this series. Now, to get that, the equation that we use is that s to infinity is equals to a 1 over minus r. And in this case, we really have an 8, 1 minus 1 over 2. And from here, really, this becomes an easy question to deal with because you just punch everything on the calculator to keep some things simple for yourself. So that should give me an answer of 16 over 3, which is the same as 5.33. And this is really out of 2 marks. And they just mark your substitution and the final answer. Now, another set of questions that we have to look at is 2.2, where we are dealing with a sigma notation. And we are given here under 2.2 the sigma notation of 4p minus 1 from p is equals to k to an upper bound of 117 there. And we're saying that if you take the sum of this series, remember this stands for the general term, so the sum of this series, if we take it from p to 177, we actually get 26,675. And you know, the difference between this question and the last question is that this question here, we are dealing with a finite series. We are dealing with a finite series. It's a series that ends. It ends exactly at term 177. That's where it ends. And you know, when we add the terms to that point, we get that number. And it's very also important to notice that this is an arithmetic sequence, because we said that arithmetic sequence will give you a linear equation. You know, that's why sometimes we call it a linear sequence or series, because you can see that this is like mx plus c. So it's a straight line, it's a linear equation, it grows linearly, we usually call it, or we usually say. Now, the first question that we're given here is that they say to us that write down the difference between T6 and T14. Remember, a difference is a number that you get after subtraction. If you subtract two numbers, the number that you get after that process, we call it a difference. So we just want to find the difference between these two terms. Now, to do that, we are going to then say we are on 2.2.1. I'm going to put a 6 here in place of p and find the term number for term 6. So for term 6, we are going to do that. And really, this is 2 marks. You don't have to write that whole thing down. They just want to see if you know how to use sigma notation. So what I'm going to do here, I'm going to say I'm having a 4 times a 6, which minus 1. So 4 times a 6 should give me a 24 minus 1. That should give me, at the end of the day, 23. So it means term 6 should be 23. Then if I do term 14, we are going to do the same operation where we say 4 times 14 minus 1. 4 times 14 is 56. 56 minus 1 should really give me 55. Then I get a 55 here. Now the difference, I'm just going to use a big capital letter D to say the difference between these two terms would be given by T14 minus T6, where now I'm going to say T14 is 55 minus 23. Remember, I said a difference is a number that you get when we subtract two numbers. So if I subtract these two terms, what is the difference between them? What is a gap that we have between them? And that gap really should be a 32. And that's how you should answer this question. And this is for 2 marks. So you'll get a mark for really computing your terms and finding the final answer there. Then the next question, which is the last question for this specific question 12 sequence and series, they say to us here under 2.2.2 to calculate the value of k. Now k, remember, is a lower bound, is there on the lower limit. So to find the value of this, there's a couple of things that we need to do. And you know, again, in my prediction, I played a lot in terms of bounds. You know, my question was testing how you should manipulate the lower bound and the upper bound. So this is a blessing here, because you should be able to play with your bounds. But before we get to that, let us do the following. we are going to rewrite our sigma notation to say we have the sigma notation of 4p minus 1, and it starts at p is equals to k and ends at, I'm going to change this to say m is equals to 117. So I'm saying my upper bound is an m, and it's a 117 because we are given, we know that this is a 117. Now we are going to expand this series to say the first term would be 4k. So what I'm doing, I'm saying if I put a k here, we're going to have a 4k minus 1 because, you know, we're saying p starts at k. Even though we don't know k, but that's where we start. Because it's a series, we're going to add to get the next term in the series. And when we add, we are going to then put the number that comes after k. Do you see that if I start with a k here, the next term that will come will be k plus 1 because we increase by 1 all the time. Remember, these are elements of integers. The p should be not integers but natural numbers. The p should be an element of natural numbers. So that it means it should be 1, 2, 3, 4, 5, and so on. So these numbers, they all increase by 1. They all increase by 1. We're always increasing by 1. So that's what I'm saying. If you have a k here as the first term, it means the next term will increase by 1. It will be k plus 1. So it means here we're going to have a 4 and we're going to have a k plus 1 minus 1. So that the next term now here would be a 4 plus 2k minus 1. Remember, if I'm saying this term here is a k plus 1 and I'm doing the next term, I'm adding a 1 here. I'm going to have a 1 plus 1, which gives me 2, and we still have a k. And if you do the next one, it will be 4k plus 3 minus 1. You know, just like that until we go to a point where we get to the last term here, m, right? And if we enter m, we then going to then put our p to be 170. Now I'll use a calculator. And this gives me here 467. And we are saying that here, remember we are told that if we add these terms from k to 117, they add up to 26,675. So that means here we're going to say this will be equal to, if you add all those, you should get 26,675. So we're saying that if we add all these terms from p equals to k until 117, which gives me that, because the end here, it's a finite series, it ends, we should get a sum of 26,675. Now, after doing this, we can see that term 1 is a and is given by 4k minus 1. You know, sometimes you can even put brackets here if you want to isolate these terms so that they're easy to identify. So that is the first term there. And there's something very interesting that you also have to check here. We have the last term. This term here is the last term. Remember, I said it's a finite series. It ends. So it ends at this term where the number of terms is 117. So this means I'm saying to you that TM, because I said this is M, is going to be the last term, right? TM is going to be the last term and is given by 467. We know that this is 467 because we can put that in here to quantify that. Now, the next thing now that comes into play, which I was talking about, to say, you know, I tested this a lot in my prediction, is to play around now with the number of terms. Now, if we want the number of terms, meaning we want to know how many terms are in this series, we are going to say the upper bound, which is m, the upper bound minus the lower bound, which is p. So we're going to say minus p, and we add a 1. We always add a 1. You know, this is a formula that's somewhere there in the notes. It's not really on the formula sheet, but it's there somewhere in the notes. We say the upper bound minus the lower bound plus 1. It should give you the number of terms in a given series. Now, after doing this, we then say we know that the upper bound is 117, right? We have it here, it's 117. And we say that the p is a k. I'm going to substitute that by k because, you know, we want to calculate the value of k here. and I'm adding a 1. So this means that n is going to be therefore 118 minus k, because when you add the 2, they give you 118. Now, if you have broken down that sigma notation in this form, you are now able to solve for the value of k, because we are going to then use the sum of a series to say Sn is equals to n over 2, and I'm going to say a plus the last term. Notice that I use this equation because I have my last term here. We've defined our last term. You can use the other equation, it will work out really well. The only difference is that it's going to be a bit long to work with that other one. Of course, I'm using the formula of the sum of an arithmetic series because I said this is an arithmetic series because I see that it's linear. That's how you see your arithmetic series. It's not geometric. Don't make that mistake. But now here, we are going to have Sn. Our n is 118 minus k. I hope you remember that. Here is our n. And I think this is the tricky thing about this question. If you get this wrong, you are out. So now here we're going to have 118 minus k. I'm just substituting the n here, because we're saying n is that number. And we're still dividing really here by a 2. And now here our first term, remember we said it is a 4k minus 1. So I'm going to have here a 4k minus 1. And our last term is really 467. And we are going to have here 467. We know that the sum of n terms, the sum of 18 minus k, meaning the sum from p equals 2k to 17, must be equal to 26,675. Because remember, this means that we are adding the terms from here to here. We must get this number. So that is the sum that we must get. Remember, sigma is the same as the sum. It's just like a Greek letter, capital letter S for the sum. So it's exactly the same thing as this one. So it means here we're going to have 26,675. And this is equals to this whole thing, which is going to be 18 minus k all over 2. Inside the brackets here, I can already combine the 1 and the 467, which this will give me a positive 466 because I'm just subtracting a 1 there. I can really multiply both sides by a 2 so that the 2 cancels and the 2 this side comes there. And this means I'm going to then have a negative k here plus 118. So what I'm doing here, I'm just rewriting this here and this here. I'm just swapping them really. And here I'm going to have a 4k plus 466. Remember I removed the 2 by multiplying the whole thing by a 2 here. So it cancelled each other out. But what I do on the right, I should also do on the left. So if we multiply this by a 2, I'll need a calculator for this. It's going to be 2 times 2, 26,675. And this says I have 53,350. 53,350. And from here you can see that I have a binomial here. I can expand that really to solve this. So I'm going to have a 53,350, and this would be equal to, now we're going to say negative k times 4k, and that should give me negative 4k squared. And we are going to say negative k times this here. This should give me negative 466k. And now we are going to say 118 times a 4. I can use a calculator for that. 118 times 4. It says we have 472. So we're going to have a plus 472k. Remember, we have a k here. And if we combine these two, you say 466 minus 472, that should give us positive 6k, right? I see a positive 6k there. And if we continue expanding, we are then going to say 118 times 4666. I can use a calculator for that. 118 times 466 and that says I'm going to have here plus 5, 4, 9, 8, 8. Now from here we then group our terms, the like terms. What I'm going to do here really is that I'm going to, because I can see a quadratic formula coming through here, I can take this to this side so that it becomes positive. I'm going to have a 4k squared. I take also this so that, you know, it's sitting next to the x squared there. I'm going to have a negative 6k. And I take this as well and put it to this side. So I'm going to have 350 minus 4,54988. You can see here that if we subtract the 2, we are going to have a negative. That's the first thing that I can do, because I can see that this number is smaller than that. And here I'm going to have an 8. I'm going to have a 361, and this is equals to 0. And we can divide this by a 2, because I can see that 2 here, you know, it's a factor, it goes in that. So it means here I'm going to have a 2k squared, I'm going to have a negative 3k. Maybe this I'll need a calculator. 1638 divided by 2, it gives me 819 is equals to 0. So really what I did here, I divided by 2 throughout. So, you know, this gives me that, and that is what we get there. Now, this I can factorize. This I can really factorize. I'll have a 2k here, I'll have a k here. And I know that the factors of 819 would really be 39 times 21. I should get 819. And I can see that for me to go back to a 3 here, I'll have to put a small number this side so that it goes with the 2 and a bigger number here. So that would mean I'll have here 21, I'll have a 39 this side. Because if we say a 2 times 21, we get here a 42. We get a 42. And if we say 39 times a k, we simply get, you know, a 39 there. But now I want to combine these two numbers so that I have a negative 3 here. And you can see that this has to be negative and this has to be positive. Because now if you say negative 42 plus a 39, that should give you a negative 3. And this negative 3 here is this one here. And of course, if you multiply these two, so if we have now here a positive and a negative, do you see that if you multiply these two, we get that number, but it's going to be negative because there's that negative there. Alternatively, you can use a calculator. You know, you can go through the quadratic equation route. That should be easy, especially if you struggle finding factors here. And this would mean that k is then equals to negative 39 over 2, or k is equals to 21. But you have to notice that the k should never be equal to the negative 39 over 2, but it can only be equal to that 21. The reason being is because k is an element of natural numbers, right? It can only be equal to 1, 2, 3, 4, and so on. Remember, it tells us the number of terms here. And this means here we are starting at term 21 and we are ending at term 117, meaning here we're starting at term 21, we are ending at 117 for us to get the sum of 26,675. And this question was really out of 5 marks. The first mark that you're going to get is really finding the value of n. Very important, is a critical element on this problem. The second mark will come from you doing the correct substitution, every correct substitution here. You are going to get another mark here, 1 mark for simplification, spending time to simplify all these things here, simplifying and so on. You are going to be awarded as well for writing the standard form of a quadratic equation. And your final answer would really come from writing the final answer. And this includes rejecting this answer here. My review, what do I think about this question? Well, I think this was a pretty straightforward question again. And it was short because it's only for 15 marks. They asked you things that are direct. The only tricky thing could have been that when you do question 2.1, I know some people might have struggled to put it in that form. And also this one, I think, people could do a mistake there and there. But also this question here appears in a number of previous question papers. It should be something that, one can take. So I think again here, if you really, really practiced, you should have been able to take the whole of the 15 marks. Again, the only comment that I can say is that because of common mistakes and that we are human beings, you could have done errors. Maybe they could cost you less than 5 marks. So this should have been, a question where you take 10 out of 15 or maybe 12 out of 15, which is still extremely good.